Let's have a look at test.py. We've looked at loop test. It's back here. Loop test.py is this big thing. All of this stuff has been pushed to GitHub. You can look at it there if you want to look at it in detail. Now I'm going to look at this code here, test.py. There we go. And we'll try to, there we go. We'll walk through it a little bit. So we import sys, import OS, import time. I'm using PBP kit, which is documented in another video, how to set it up. It's in the /pbp directory, and the kernel is in there too. We import the kernel. I created a class locally for what I'm going to do here, and I need to create 3 routines. An installer. This installs the template for this part. An instantiator, which creates a unique instance of this part. It's kind of like instancing a class in OOP or whatever. And then a handler, which gets the kernel data structure called A. It should be a Unicode symbol here. E with a dot above it. It's pronounced A. In Canadian, it's pronounced A. In ASCII, it's spelled this way, EH. And then it gets an event, which is really just a string payload tagged with a port message. Gonna look at pbp/kernel 0 detail hi find new event. That's down here. Yeah, so there's a port and a datum. Well, again, this is historical, but a datum has a .v component, and the .v component at the moment is always a string. I used to have more complicated things hanging off of it, but I found that you don't really need all that. And all these line numbers and things here, this code is automatically generated from one of these diagrams in the PBP development directory, and these line numbers refer to the original .rt source code for this. So in the source code, this line, this definition of the object event is at line 43 of the original code. That would be in PBP dev. PBP dev. No, not PBP dev. Projects. No. Dev. Kernel 0d.rt. Yes, if we go to line 43, we end up at the definition of the event object, which is a port and a datum initialized to none, initialized to none. I'm using this meta syntax so that I can generate 3 different languages from the same definition of the kernel. Currently I'm generating Python, JavaScript, and Common Lisp. I guess I could do more, but I don't have time. And so in Python, this is what we get out of that object definition. And why don't I see if I can go back there. We're talking about this piece of code. That piece of meta code turns into this piece of Python code. Again, I wasn't going there. I was looking at what the insides of that thing look like. There, I'll go back to here. And so I was talking about install and instantiate and then a handler, which is the step function for this. Well, no, it's the message, the event receiver. So every time an event is fired at this thing, it goes into its queue, and then the kernel decides that you've got more than 0 things in your input queue and says, go handle the first one. And that's what this thing does. It handles the first one. And from this A data structure, we can get the instance data related, which is an instance of this thing. And then we do a try except, and then we just, this should probably be written differently in more modern Python. I just wrote it out as an if then else. Probably it's a case statement, a match statement, I think it is in Python, but I can't be bothered at the moment. So I'm checking the port of the event to see if it's width or height or reverse. And if it's width, I just set the width of this instance variable, this thing here, to be whatever just came in, turned into an integer. Same with height. And if it's reverse, then I multiply the current direction by -1. It starts off with +1, goes to -1, goes back to +1, goes back to -1 every time one of these revs comes in. And the x, what's going on here? Here I'm dividing by 20. Well, earlier I said I divided this up into 10 steps. I'm actually dividing it up into 20 steps. I'm taking the current direction, either going from left to right, which would be +1, or going from right to left, which is -1, changing the integer offset, which is between 0 and 800, or actually 1/20th of the full offset, and adding it in the right direction to the current x. And then if we get something on the nothing port, which is equivalent to the stood-in port, then we go into a little state machine that says if we're idle at the moment, then this is the first time. So we start off in idle, and if it's idle, then we send out a paddle, X and Y here, and we construct the string to be legal-looking JSON that doesn't confuse the very simple knowledge that I have of Python. And we send that out here on this port, and then on the other port, the X port, this port. Why have I got this? There. No. Yeah, there. So on this X port, we send out just the X value as a string. And what we're seeing here is something that may look odd to functional programmers. We're not putting out a struct containing 2 values. We're putting out 2 separate values, and they're being queued up on the output queue of the test part, of this part. And then we were in idle. We go to looping, which says basically, there's basically only 2 states in this ridiculously simple state machine, idle or looping. Looping is the steady state version of this thing. Idle is the first time through version. And what we always do is we increment X in the correct direction, and then we send out the full JSON for the ball, and we send out just the X value on the X port. So we send this out, and then we send that out every time. And in this case, since we're bootstrapping, I'm also double checking to see that I'm not sending garbage messages into this part. And if there's any kind of bizarre exception, we also send it out. We're sending out error messages on this ballot X port. That's a Unicode X, Unicode ballot X, instead of the ASCII X up here. That happens every time, on every incoming message that gets fired. This routine gets fired. And I've described this other stuff before.